Welcome to Pomodoro Joe for Friday, May 5th, 2023. Happy Cinco de Mayo, everyone. Today we're doing LeetCode problem 1456, maximum number of vowels in a substring of given length. This is a medium problem. Given a string s and an integer k, return the maximum number of vowel letters in any substring of s with length k. Vowel letters in English are A, E, I, O, and U. All right, and then we have some constraints, but this should be pretty straightforward, so we'll put 25 minutes on the Pomodoro timer and get started. So anytime I see something that says a given length or a fixed length, something like that, my immediate thought is to use some sliding window. So a sliding window is, let's see if I can explain it. Imagine if you had an index card and you cut a little square window or rectangular window out of that index card. Now, if you held that index card up to a book or a newspaper over a sentence, a certain number of letters would just fit within that little window that you can see through the index card. Now, if you slide that index card along the sentence, some letters will be shifted out of the window and new letters will be shifted into that window. So that's exactly what we're going to do here with our own sort of sliding window inside of our string s. So we'll have to keep our low index and our high index, and then our window is everything in between. So let's start out with some result, and we'll set it equal to 0 to start, because that could be our maximum, and then we will return the result at the end. All right, so the couple things I'll want to define here. I want to define my low and high index for my window. So I'll have low, and we'll start at 0, and we'll have high, which will also start at 0. Let's see, I'll also need to know when I've reached my maximum index, so I'll just keep the length of string in length s. That way I don't run out of bounds with my window. Okay, so I have my low, my high, and then I'll also want to keep track of the current count of vowels within this window. So the count will equal 0 to start with. Now, the way I'll be doing this one, we'll essentially build up our window to start with. We'll just go from 0 to k, moving our high index. That builds our initial window. Low will stay at 0, high will move up to k, and everything in between defines our window. We'll count all the vowels in that initial window. Now, as we move the window to the right, we'll move the entire window to the right. So both low and high indices will be moving from left to right, sliding our entire window left to right. As new letters shift into the window from the right, we'll count them if they are vowels. And as old letters shift out of the window from the left-hand side, we'll reduce our count if those letters were vowels and they no longer exist inside of our window. So that's kind of how this is going to work. Okay, so I'll do my initial count first. So this is going to be my initial window. Let's see, so I need, while my high index is less than, well, I need to have two conditions here. It has to be less than our length of s, because we don't want to go out of bounds. And, let's see, it also has to be less than k. So let's make sure we get our bounds right with this one. If k is 1, that means the window can be of size 1. Now our low will be 0, our high will be 0, so initially it will be less than 1. We'll integrate this one character at index 0, then high will be moved to index 1, it will be equal to k, and then we'll break out of this loop. So I think this is right. We want high less than k. So we'll just grab this letter here. So we'll say if s at high is in vowels. Oh, okay, we don't have anything that defines our vowels, so we will also need this. So in addition to the length, we'll need vowels. And I'll just make this a string, A, E, I, O, and U. So that's pretty easy. In Python, you can do this as a string. Other languages, you might need to do some type of an array or a set, but for this, we'll just say it's a string, A, E, I, O, U. So if the character in string at index high is in our vowels, then we'll just add this to our count. So we have one more vowel. If it's not, we can just ignore it. Now we need to advance our high index. Okay, so this will take our high index from 0 to k essentially. That's just building up our initial window. So those are going to incorporate all of the vowels from 0 to index k, but not including index k. Next, we need to actually start sliding the window. All right, now to slide the window, we need to actually move both the low and the high indices all the way up into the point where our high index is at the end. So this is kind of the same. While high is less than our length s. So now we can start moving this entire window. And it's pretty similar. I'm just going to, in fact, it's so similar, I'm just going to grab this. Okay, now the main difference is here. So as we're sliding our window, if the new character at the new high index is in the vowel, we'll increment our count. Now, if we move our low index, so we need to check as we move our low index to the right, if the character that was at our previous low index is in the vowels, we need to decrement our count because that vowel is now leaving our window. And then, of course, we need to increment both of our indices here. So low plus equals 1 and high plus equals 1. Now, one thing to note here, I'm not actually doing anything, I'm not incrementing our high before we get into this loop because it's already been incremented at the end of this loop. So we're already on sort of the next available character for our window. So we can check to see if the high character is a vowel. If it is, we'll increment our count. If the low character was a vowel and it's moving out of our window, we decrement our count. And then we increment our low and our high, so we're shifting our entire window to the right. Now, one thing I haven't done is check to see if we have a new result. So every time we change our count, we may have a new result. So let's just check that here. So our result will be the maximum of our current result or the current count. So I could say max result and count. I'll do this for now. I'll probably come back and change that to a manual max because it's a little bit faster. All right, so I think this should do it. Let's give this a shot and see how many typos I made. No typos. Seems to work. Let's submit this and see how we do. We get a wrong answer. Let's see, we're off by 1. So I'm going to use this test case and then see what we did wrong here. All right, so we have our length, we have AEIOU, we have our low count, we have our low index, our high index, we have our count. Let's see. Oh, one thing I didn't do is this count, we've already been updating our count here. It's possible that this count, before we start sliding the window, is actually the maximum count, which means that this result up here is kind of useless. Let's pull this result down. Let's put it in here. So at this point, we might actually have a result, and it will be count. Okay, I think that should handle this. Let's see if that fixes this one test case. And it does. And we pass. So we do okay. We beat 68% for runtime, 14% for memory. Not too bad. Let's jump back here and do our own manual max. So in this case, we are doing the maximum of the result or count. We could also say it will be count if count is greater than result, else result. So this should be a little bit faster, assuming I didn't make any typos. All right, let's see if this gives us a little boost. Huge boost, in fact. So we go from a 68% for runtime to a 95% for runtime and a 14% for memory. That is a huge boost in performance. All right, so that's basically it. You can go in, you can tweak this a little bit. You can shorten some of these variable names. You can shorten up some of these spaces. There are certain things you can do to make this a little bit faster, but I'd say 95% isn't too bad. All right, well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.